So 5. This is where it starts getting pretty fun. Alright. Alright, so if we want to arrange 5 things around a central atom, kind of look right now, kind of think North Pole, South Pole, and then we're going to have 3 in the equator. So it's kind of like a trigonal planar and a linear all mashed together. Alright? So if we start on that first row, 5 bonding areas, no lone areas, 5 plus 0 is 5. The geometry of this and the shape of this are going to be trigonal bi-pyramidal. So we basically have a pyramid on the top, we have a pyramid on the bottom, so trigonal bi-pyramidal because we have 2 pyramids. Bond angles, there's several that can happen. They can either be 180 from north to south pole, they can be 120 right between our equators, and they can also be 90 between North Pole and equator. So several different bond angles that apply, in some more than others. I would say in this particular instance we'd have 90 and 120. All right, but the bond angle between north and south isn't going to be that prevalent necessarily. All right, so if I take one of these off, the question really becomes: is it better to take a North Pole off or an equator off? So if I take a North Pole off, notice these are still 90 in 3 ways and 120 in 3 ways. All right. If I take this guy off, I've got 90 in 2 ways, 120 in 1 way, and then I have like 240. So it's actually better to take them off the equator. So in that second row, we're going to have 5 bonding, 1 lone. 5 plus 1 is 5. In this shape, this is where it was just like late Friday afternoon in the chemistry lab as they're naming stuff, and you got these trigonal pyramidal and trigonal bipyramidal, and someone's like, hey, you should put it on its side, look, it's a seesaw. So this is actually called seesaw, or teeter-totter, alright, because it actually looks like a seesaw, or a teeter-totter. And once again, bond angles are going to stay the same. And so if you take another one off, okay, so we have 3 bonding, 2 lone. And I don't know if it's the same Friday, different Friday. What was this one called? This is called T-shaped, because what's left, it looks like a T. So T-shaped. And once again, bond angle and hybridization, same. If we can lose one more, if we do lose one more, we've got this. So this would be 2 bonding, 3 lone. And you can see here this is definitely a 180 bond angle. Alright, so it doesn't apply every time, but it applies in this instance for sure. So if we have 2 bonding, 3 lone, the shape is linear, and bond angle in this particular instance would only be 180. Just like if we put this one on, it would be 180 and 90. So you just kind of have to play it by ear. There's several bond angles possible with the shape, and you just have to kind of have the shape in your mind, have it drawn out, and be able to tell what you're drawing when you draw your Lewis structure, whether you can see it on the paper or see it in your mind. All right. So last one is these one with 6 areas, and there's only 3 of them, so it's actually a little bit easier. And we're just going to have like North Pole, South Pole, East, West. Turn it one more direction, East, West again. So it kind of looks like a kind of like a Rubik's cube, planes of a Rubik's cube, something kind of like that. Okay. So 6 bonding, no lone. This geometry and the shape are octahedral. So I have 1, 2, 3, 4, 5, 6, 7, 8 sides, so octahedral. Bond angles in this particular one are going to be 90, but it can't have 90 and 180. Alright, we'll see that in a second. Alright, so it doesn't matter which one of these I take off. I can take one of them off, because they're all equally, they were all 90 degrees from each other beforehand. So again, pretend this doesn't exist. Well, actually, we can do our 5 bonding, 1 lone. So pretend this doesn't exist. So it looks like a pyramid again, if we were to connect the white balls. But now, from the top, it's no longer a triangle, it's a square. So this is a square pyramid, or square pyramidal. And bond angle, again, we're going to have 180 and 90 this time. And then the last shape will be from the opposite side. All right. So this would be 4 bonding, 2 lone. Geometry is still octahedral, but our shape is now going to be square, planar. All right. So it looks like a square from one side we rotate it 90 degrees, we can see that all the elements are in the same plane. All the atoms are. 2, and bond angles in this case 90 again between our equators and 180 kind of across our poles. So that is VSEPR really quickly.